Well, good afternoon. It's a great sunny day here in Seattle. I'm back from vacation with my wife. Very happy to be back with the hounds and everything. Anyway, getting back to the auction score, I thought I'd take a shot at seeing if what the issue is with this E4406A. So let's boot this on, and while it's booting up, we'll refresh it. Let me grab a drink. I'm still horribly jet lagged, so the drink of choice is a coffee. Okay, if you remember back to the previous video, what was going on with this device here was that it was reading about 15 dB down, and that seemed to be consistent no matter what the attenuation was that I checked. So here we can see that it's started the boot process, and pretty soon we should see it come up and show that it's going to do its self-tests. I believe this is, I think I said this was a Linux-based machine previously. This is it's actually a HP UX or HP RTOS, I think. If you look back here, that's what you might have seen. But it's a HP Unix version, not a straight Linux one. There we go, HP RT PA RISC based HP RTOS kernel. So we're going to log in now, and then it should get up and start running through its self-tests. And here we go, we're now starting to run through the various self-tests. Now this is important, and we'll cover this just in a moment. Okay, if you see here, you saw right at one of the last tests there was the attenuator steps. Now, the design of this system, and we'll take a look at it, you have coming into here, if we just scroll across a bit, you have coming into here the signal goes through a 7 dB attenuator and then is off into the RF board that's inside the device. So what we were seeing here is, and I have my 8657B connected. Let me just turn that on, and let me set the frequency. And here you can see, if I bring a marker in, you'll see them about 16.2 dB down. Now, I know that my 8657B at 50 megahertz should really be, I think, about 0.2 of a dB low, and the cable probably contributes a little bit as well. So we've got a significantly high amount there. Now if I come in here and select system, system, and we show errors, we have no errors. If we come back to system, no, hang on. Input attenuation. You'll see the input attenuation here, and I played with this so a little bit more. If I go have a look at, say, 40 dB, what you'll notice is that we still have our minus 15 signal here, but the noise floor of the instrument has risen exponentially. So this is what the attenuator is doing. It's basically putting itself in play, and then the software modifies the display because it knows what the input signal is, but then it can take out that input attenuator so that you still get the resultant value here. So once I'd spoken to a few people that have been familiar with these units, and they pointed this out, that enabled me to start looking at that architecture. Now, what could go wrong with this is that on the RF board there is a solid state attenuator, and maybe that IC itself had blown. But that pass that we saw in the self-tests, where it showed that the attenuator steps had passed, that indicates to you that the attenuator on the board itself is working. So let's shut this guy down. We'll turn off the RF over here. We'll pop the top on the unit. We'll take a look inside and see what we're going, and see if we can easily test that SMA attenuator. Okay, so we have the cover off now, and here you can see quite a nice little graphic on the center cover, the internal shielding of the unit that shows you the basic block layout of where things are. So the front panel is up over here, that's that N-type connector, and it comes into this 7 dB pad, and then it follows a semi-rigid cable around, and then that semi-rigid cable basically ends up coming into the RF board here, so which we see here. So that, when I took the cover off the unit first, that 7 dB pad item was there, and so if we take a look at the actual block diagram, this is out of the manual, and let me just zoom in a bit so you can see this a bit better. What you'll see is that AT1 is a 7 dB attenuator that comes in from the RF input, and then it goes into the RF assembly. Now in here, there's the actual 40 dB attenuator that is inside the unit. And this is a solid state attenuator, as we'll see in a moment. But you'll notice that it does the calibration and the check, and it does that through this 50 megahertz input. Now this 50 megahertz input comes from inside the unit, and you'll see that it comes into a relay here. And this relay here was that important thing. That's why I pointed out that it passed the self-test. If we actually go have a look at the clip for this, you can see that that's the RF signal coming in. So that SMA attenuator is out here. The 50 cal comes into U38, which is the relay here, and then that gives pass into the solid state 40 dB relay, which is AT1, before it goes off into the rest of the unit. So if it's passing the attenuator test here, that means this relay is actually coming over and hitting the 50 cal, the 50 megahertz cal line here, and then the attenuator is doing the correct work. So what that led me to believe, based on that and the feedback from other people in the forum, that it really was the 7 dB attenuator. So let's get this internal cover off, and then we'll take a look at the unit. Okay, here we go. This is the unit here. Like all HP units and Keysight units and Agilent units, just fantastically engineered. This is the RF board on the side here, and if we flip it over, you might be able to just see in, really can't quite see in the side there. You might just be able to see in there's the attenuator in there. Now that's going to make it a little hard to test. So if we take this RF cam out, you'll see the RF connections are coming in over here, and if we turn this around a bit, you should be able to see that piece of hard line here, the piece of hard line here that comes up from this port here, goes across and into here, goes across and into here, and that comes out on this connector there. So what I can try and do is see if there's a way for me to get into that. That looks like I might just be able to pop the front cover off. Anyway, I might have to take a quick look at the service manual, and we'll check that out. Alright, so it seems to imply that the front face can be dropped without removing any cables. So let's see if we take these screws out. Oh, for God's sake. Alright, and they are identical, I think, to the other ones. Let's make sure of that before I get them confused. Design tip if you're ever building this gear is minimize the number of types of screws. You're going to make BOM cost and servicing much easier and cheaper. Okay, well, let's try the other side. Now, if this works, this whole front, if this works, this entire front cover should just fold off. Okay, there we go. So now, let's see if we can just pop this cover off. And by Jove, it does. And here we go. As you can see, the cover has just popped off there. So that should give me access. Actually, probably looks easier for me to do this. There we go. Okay, so let's, there we go. Okay, so now I should just be able to do that. And there we go, there's our little high operating surface temperature, caution, 5 watts. It's a little Winchell device. So now's a chance for us to test that. Let me just push this cover back on. Okay, so now I have my power meter. Let's zero this because I've just hooked it together. So we'll press 0. Okay, and now I should be able to press Cal, and we should see there should be a little light that flashed on here, and it should just calibrated. Okay, so now if I take my little sensor, this is an E4406A sensor, and so let me just put this in here. And now, just below here, let me just move this out of the road a bit. This is going to be, we're going to effectively eventually put this guy in between here. But let's start with a reading that we need to make to ensure that we're at or close to 0 dBm. So let's turn that RF on. And there you go. With this all in, I am at minus 0.61. So if I turn the RF off now and we take this out, dropping this guy in here should give us a minus 7.61 dBm item. Feels bent. Okay, so we'll drop that guy in there. Okay, now let's turn that RF on. Okay, well, that's a little bit concerning because what that shows then is that things are okay if we, with that, I'll let you put amplitude minus. Amplitude or minus 10 dB, and we should be reading minus 17, which we are, and put 1 gigahertz through that. Oh, I may have, oh, did I just turn that off? Bummer. I have to turn that back on. Now we're going to calibrate it. You'll see the little yellow light come on there. Okay, now I need to set the frequency. And I had the frequency set for 50 meg, so let's set it for 1 gigahertz. Okay, and let's put this guy back in here. And I think we should probably still be very close to that 7 dB mark. We probably have a little bit more farther because the line loss of this is about a dB, I think, at 1 gigahertz. So let's set that. Its amplitude as 0 dBm. And there we go. We're about -8. So that implies that that's working fine. Okay, so now the next thing that I'll need to look into is that hard line. So now I'm going to have to see if I can find a connector to check that. Just while I was at it, I thought I would check the N-type at the front of the unit as well. And as you can see, that it's good for that value too. So we'll need to keep looking. Okay, so there doesn't appear to be any way to the hardline has, you know, an SMA on one end and then connects into the RF module here on that end. So there doesn't appear to be any way to any connectors on there. So let's take a look inside the little can here and see what we see. There we go. It's a beautiful looking board. You can see all the different, I won't turn the lid over here, but you can see all the different sections that have all been canned off from interference. Anyway, this is where we come in here, and so if I carefully take this board out, I'm guessing we're probably going to see that's going to most likely be the attenuator. Let's see if we can, let me zoom in a bit, see if you can see a bit closer. I think that is going to be the attenuator that's in that first part of the circuit. Now the U38 is the, okay, so that there is the relay. This is coming into, it's coming into this guy here, and that's going to be the relay that's going to switch in the 50 ohm internal circuit there, and then that will connect to, and that's not actually silk screened on the bottom here at all, which is disappointing, but I think that's the attenuator chip there, because nothing else in that area, that you can see is labeled. So if we look at the bottom over here, you'll notice that nothing there seems to be labeled. Hang on, let me just make it absolutely certain. Yeah, there's nothing labeled there. And so if we look at like the diagram again, you can see that we come into U38, and then from there we go into AT1, and nothing's labeled AT1, and then Z2 is this guy here, which is going to be the mixer here for the RF. So Z2 is going to be this mixer here, And so this is a 50 cal, so the only thing that it could be doing would be, and now if this relay was working, you would be getting the right level of attenuation there, and that would be passing. So the only thing I can think of is that there must be something wrong with U38 here. So anyway, that's a beautiful looking board. These guys really know what they're doing, far and away anything that I would know. Anyway, that's, I think where we're going to end up is needing to, let me zoom back out again, needing to look into U38. I don't know if there's a way that I can do this with the unit with the top off to see what's happening there. We'll probably have to go and reach out to some people that use this and then find out. Anyway, whoops. I hope that's part one of the work here, the RF gasket. You can see beautiful the way it's all worked there. Anyway, this is part one of the work here on this, on getting this to work again. So hopefully you found that interesting, and when I know a little bit more about whether I'm going to be able to get a replacement for U38, I will get part two going. Alright, catch you later. Bye. One last thing before I go, and that I wanted to make sure that it occurred to me that maybe, if the 50 megahertz calibration signal is wrong, then so would the output or the measured value from the system. So what it's telling me to do is to go set a go up a page. To go set a 50 megahertz output at minus 25 dBm plus or minus 0.2. So if I put in minus 25, amplitude minus 25 dBm. Alright, so it's 0.6, so to amplitude do increment 0.1 dBm. So alright, so there we go. That's the value coming out of my signal generator. So right now I should be pretty, damn close to 25 dBm on that. So it says to get on here and let me move, and let me take this guy just out of the road here. Alright, let's zoom in. So now what it's saying is that the alignment should all pass. Now you see the attenuator steps, it'll say pass there. Yeah. So, okay. So now what it's asking me to do is to go okay. So press, if we do this, we press mode, and then I'm going to go and select service. Okay. And then I press frequency, and then 50 megahertz. And then we'll see center frequency 50 megahertz there. Okay. Now press system, and then more, and then show system, then service password. Now according to the manual, the password is 737 8423, and press enter. So now press system, alignments, align subsystem, an aligned 50 megahertz reference. Okay, and we had 25 dB, so you can leave that as minus 25, and so let's set adjust now. Okay. So I'm guessing that saying signal out of range, it means that it's not picking up the internal signal. So that's probably a case of the system being broken. You know, that not broken, but that minus 15 dB. So if that, you know, if it's really reading minus 16, then it's never going to read minus 25 to actually do the correct input level. Anyway, I hope you found that this interesting, even though with that I also, if you look up, I also poked the hard line, and that didn't have any impact on the actual values either. If we go back, you see that there, and we can move that around, and I checked the tightness here with my proper torque spanner. It's all correct, so it's looking more and more like U38. Anyway, we'll get back to this later, and we'll see how it goes. Alright, catch you later. Bye.